Next up is repeated linear factors. So you see here, it's almost like the previous one, but instead of just x plus 1, I have x plus 1 squared. So I have to take that into account when I do my decomposition, right? So here's the thing. Remember, when you're making a common denominator, you might have a situation here where, let's say I had x plus 1 squared and I had x plus 1 and I had x plus 2, right? A, B, C. So the common denominator for this is this guy, even though, so here I don't see an additional x plus 1, right? But if I were to make a common denominator for these guys, you know it would just be x plus 1 and x plus 1 squared, x plus 1 squared times x plus 2, because this x plus 1 would just kind of, it would be in there, right? So whenever you have a repeated factor, of course, repeated linear factor, you always have to go down 1. And so you don't necessarily know when this decomposition is done. I mean, it's possible for some of these A's, B's, and C's to be 0. You may not have a B. You'll definitely have to have an A or a C, but that middle one, you may not have a B. However, you may very well have a B. Whether that is there or not is going to depend on what's up here. So you have to have it in there, otherwise it won't work out right. So just before we go through this, and we'll go through this in detail, but just to think about it, if I had repeated linear factors, something like another example, which I'm not going to go through, something like this. Okay, so I've got one simple linear factor. This has no power. This guy has a power of 2, and this guy's a power of 3. And I just put 1 in the top because whatever. So what I'd have to do if I was going to do the partial fraction decomposition, I would have to take care of every possibility, right? So I would have to go x minus 2 cubed, x minus 2 squared, and x minus 2. Then I'd have to go to x plus 5 squared, and then I'd have to go to x plus 5, right? Because I still have to step down from whatever my power n is. And now I ran out of space, I'll also put down here f over x minus 1. So if you were in a situation where you had to integrate this, yeah, you'd have to do that, and you'd have to solve for all those coefficients. But you know, this is what they made computers for, right? And in fact, even like if you actually had to do this, you'd probably just stick it in Mathematica or whatever. It can do it. It can do it. Software can do it. But we don't need software to do something like this. This is not too bad at all. Though actually, come to think of it, probably let's see where we get. Okay. So as I said, back to the problem at hand. That's the common denominator. What I want to do here is I'm going to, what I get is I'm going to get A times x plus 2. Now notice B only has one x plus 1 in it, so I have to multiply by another x plus 1 and another x plus 2. And C has the x plus 2, so I got C times x plus 1 quantity squared. All right. Well, now if we work all this out, I have ax plus 2a plus, this is x squared plus 3x plus 2. So bx squared plus 3bx plus 2b plus, and then this is x squared plus 2x plus 1. So cx squared plus 2cx plus c. All right, so yeah, maybe writing those down in 2 steps is probably better than doing it in your head. Okay, so what I'm going to do is I'm going to get my like terms together. First, I'm going to pick everything with an x squared out. Bx squared, cx squared. So this is going to be b plus c times x squared. And I like to cross them off because that keeps it straightforward for me. So for my x terms, I have ax, I have 3bx, and then I have 2cx. And then for my constant terms, I have 2a plus 2b plus c. Okay. Now I'm going to equate these, and that's going to give me my system of equations. So all the coefficients here on the left-hand side are 1. So what I pull out is that b plus c has to be equal to 1, that a plus 3b plus 2c has to equal 1, and 2a plus 2b plus c has to equal 1. And it's not very... Anyway, that was the system of equations that I pulled out from there. Yeah, and so how do you solve these? Well, any way you like, right? You can eliminate the a from these two, then you'll have 2 things for b plus c and just solve from those. So this is not too hard to do that way. I did it with matrices. If you do it with your calculator, that's fine. I don't care how you do it, as long as you tell me what you did. It turns out this is the wrong problem. I'm like, that's not right. It turns out the answer is a equals 1, b equals -2, and c equals 3. Okay? So now I go back. I'm not done yet. I still have to do the integral, right? Because this is calculus. It's not this algebra stuff from high school. Okay, so I put this in here. I have 1 over x plus 1 squared plus, or sorry, minus 2 over x plus 1 plus 3 over x plus 2 dx. Okay. So now I can go ahead and integrate those. All 3 easy integrals, but of course now I have this guy squared, so it's not a natural log anymore, because this, if I use substitute, right, I've got du over u squared, so in fact it will be minus u to the minus 1. We get that, and then this will be minus 2 natural log of this guy plus 3 natural log of this guy. So that is what you get. I don't know what happened to my answer. Yeah, there it is. Okay.